Welcome to the CoSpaceRobot family. CoSpaceRobot is an official platform for both RoboCup and RoboCup Asia-Pacific CoSpace Challenge. CoSpace Autonomous Driving Platform is powered by CoSpaceRobot Studio. Apart from the CoSpace programming interface, it provides interface in Scratch, Python, and C. Please visit our website to find out more.
If you have some experience with programming or have completed CoSpace Auto Driving First Steps, the Auto Driving U12 is designed for you. In this session, we will give you a step-by-step guidance to the CoSpace Auto Driving. We hope it will help you to have a better understanding in the CoSpace Auto Driving Intermediate level and to take part in the CoSpace Autonomous Driving Challenge U12 category.
Line following is probably the most common application in robotics. It is widely used in industries and even hospitals. If a robot can think, the thought process of a line following robot will be very similar to that of a human being. And that can be simplified into 3 actions: sense, plan, and act. CoSpaceRobot will give you a unique first-hand programming experience in such applications. Let's take a look at the CoSpace Virtual Robot. It is equipped with one color sensor to sense the floor RGB color, which is the short form for red, green, and blue. One gyro sensor to sense the robot's orientation. One ultrasonic sensor to sense the front obstacles, and 6 infrared IR sensors for line tracking. What is the logic behind the robot's thinking process when it tracks a black line? The 6 IR sensors mounted on the robot are like 6 eyes of the robot. When the first left IR sensor, we call it L1, senses the black line, the robot needs to move forward. When the first right IR sensor, we call it R1, senses the black line, the robot also needs to move forward. When L2 senses the black line, the robot needs to turn left slightly. When R2 senses the black line, the robot needs to turn right slightly. When L3 senses the black line, the robot needs to turn left rapidly. When R3 senses the black line, the robot needs to turn right rapidly. This process repeats forever in a loop, and this will ensure that the robot tracks the black line. Let's code a line tracking program in CoSpaceRobot.
For optimal performance, your PC laptop should meet the minimum configuration. Let's watch a video guide on installation.
Hello, good job. We are almost there. Let's click on the Experience button to see if our computer is compatible with this software. While we are at it, let's also check and see the version of our software. It's always good to have the latest version. Awesome, it seems that our computer is compatible and our software is up to date. And now it's time to activate our software. So there are 3 options: Learn, Compete, and Experience. So for this example, we're going to use first steps. Right, we're going to click on Workshop Pack 1. The activation window has just popped out. So please make sure you're connected to the internet and input your account number as well as your serial code, which is also your license number. So these will be given to you via email, so please make sure to check your email. And also please make sure when you put in your serial code, there are no spaces in the front and at the back, because the serial code is case sensitive.
Double-click on the CoSpace auto-driving icon on your desktop. Now, choose your level and map, which is also known as our virtual environment. We will use CoSpace auto-driving first steps as an example for illustration here. Frame rate, it is also called FPS, is a very important parameter. It will affect the robot performance if it is too low. You can check the frame rate on the status bar. It is highly recommended to keep the frame rate greater than 15 for robot smooth performance. If the frame rate is less than 15, you should change the display resolution to 1366 x 768. After changing the resolution, monitor the frame rate again. If the frame rate is still less than 15, you can change the rendering quality to low. The frame rate should be greater than 15 finally. To adjust the virtual environment, first, click anywhere in the virtual environment, and then, press the Q, W, E, A, S, D keys to adjust the 3D view. If you press Shift together with the keys, it will make the movement faster. If you mess up the environment, you need to click on the control panel and then click on Ctrl+H together to reset the virtual environment to the home position. To manually control the virtual robot, first, click anywhere on the control panel, and then, press the 4 arrow keys to move the virtual robot manually. As you know, there are IR sensors, ultrasonic sensors, RGB sensors and gyroscopes are installed on both real and virtual robot. While the robot is moving, the live sensor data will be shown on the control panel. Double-click on the CoSpace auto-driving icon on your desktop. Now, choose your level and map, which is also known as our virtual environment. We will use CoSpace auto-driving first steps as an example for illustration here. Double-click on the AI button to enter the programming interface. First of all, you will need to create a new project. Click on the New Project button. Please remember to give this program a team ID, a team name, a project name. Remember, once team ID and team name are confirmed, they cannot be changed anymore. However, you can change the project name if you wish. Based on the analysis earlier, we now need to convert the logic into code which the robot can execute. The first statement should tell the robot that when L1 senses the white line, the robot needs to move forward. Step 1. Let's create a statement named L1 senses white line. Step 2. After the statement name is defined, we will add conditions to this statement. We click on L1 until it turns white in color. This means L1 will sense for the white line. Step 3. We should tell the robot what to do when the condition is met. In this scenario, the robot should move forward. That means both wheels should have the same speed. Step 4. Finally, click on Preview button to see whether you have set the correct wheel speed. Great! We have completed our first statement. Repeat the 4 steps above to complete statements 2 to 6. Statement 2. When R1 senses the white line. robot moves forward. This is similar to statement 1. Make sure we have set the same speed for both wheels. Statement 3. When L2 senses the white line, robot turns left slightly. This time, we will set different speeds to the left and right wheels. As the robot turns slightly, the speed difference should be small. Same concept applies to statement 4. This time, the robot turns right slightly. Statement 5. When L3 senses the white line. This means that the robot is almost off track, so the robot needs to turn left quickly. This time, we can set the left motor speed to be negative and keep the right motor speed positive. Same concept applies to statement 6. This time, the robot should turn right quickly. After we have completed our program, we should do a quick check that the logic is correct and make sure every statement has conditions and actions. Once you have completed programming, it is very important to save and build. Save means to save the most recent program that you have just completed. Build means to check syntax errors, create a C code and a dynamic data link file with extension DLL. Now you can click on the preview button to see how the robot will behave. If you wish to modify the program, click on the Stop button and you will go back to the AI panel to modify the program. Now, you can load the program which has been compiled as a DLL file using the Load button in the control panel. After successful loading, we can use the Play, Pause and Stop buttons to control the robot's movement. We can monitor the robot's performance in the control panel. We can monitor the robot's movement from different perspectives. You can select different viewing camera from the menu bar. Choosing main camera will let you to have the global view or bird's eye view of the environment. Choosing CS-Bot front camera will let you to have a first-person view or driver's view. Choosing CS-Bot following camera will let you to have a helicopter tracking view. You can also to have the global view and first-person view in separate windows. Changing position and size settings will change the separate window attributes. Well done! CoSpace Auto Driving Intermediate Level allows you to program the robot in Python. Let's take my first program in first steps as an example for illustration. Open my first program. Click on Python icon. Your CoSpace program will be automatically converted into Python code. The Python code consists of variable definitions, system functions, and AI function which you can modify. Let's look at the first statement. When L1 senses white line, the robot moves forward with both wheel speed +30. The highlighted segment in the right window shows the interpretation. Let's modify both speeds to +70 for statement 1 and statement 2. Save the Python code as my first Python. The Python code will have an extension of py. Load the Python file myfirstpython.py in the control panel. Run the program. Well done. You have completed the first Python program. If you want to have more example on how to code CoSpaceRobot in Python, please visit RCAP Academy YouTube channel. Let's work on task 1. The task 1 is to program the robot car to travel around the knowledge park. The robot car starts its journey from the start station. It must pass through all waypoints before stopping at the destination. During the challenge, apart from line tracking, the robot needs to use the ultrasonic sensor to measure the distance to the front wall and make a correct turn when it approaches the wall. The ultrasonic sensor is mounted at the front of the robot. It senses the front obstacles and provides feedback in cm. When the robot moves forward, we can monitor the live feedback data on the control panel. To program the ultrasonic sensor, you have to specify the range of distance as a condition, then set the robot action to be taken when the condition is met. Please program your robot to complete the task. The sample code can be found in PPT slides. Well done. Let's work on task 2. Let's work on task 2. The task 2 is to program the robot to navigate the maze. The robot needs to use the RGB color sensor to detect the color patches on the floor. Together with using the ultrasonic sensor, the robot has to make correct decisions during navigation. The RGB sensor is mounted at the front right corner of the robot, facing downwards. The RGB sensor detects colors. It outputs the exact color it detects, in terms of the red, green and blue light intensities. Each channel value can range from 0 to 255. Move the robot manually. Let the RGB color sensor sense the color patch. The RGB sensor gives 3 readings for each color detected. They are the corresponding red channel reading, green channel reading, and blue channel reading. Just like programming other sensors, you need to specify the range of all 3 channels of the RGB sensor values as the condition, then set the action to be taken when the condition is met. Please program your robot to complete the task. The sample code can be found in PPT slides. Well done. Let's work on task 3. Let's work on task 3. The task 3 is to program the robot car to travel towards the destination. During its journey, it must pass through all waypoints before reaching the destination. To complete this task, the robot needs to track the black line, avoid obstacles, detect floor colors and make correct decisions. You can use the time sequence or state variable to program the robot. Now, let's write a simple code for this task using a time sequence. You can divide the whole journey into a few sections, and then let the robot take certain actions within each time frame. Using a time sequence is the first technique we need to learn. You may use task 1 as a reference to program the robot to complete the task. The sample code can be found in the PPT slides. In the CoSpace Auto-Driving Intermediate level, you can also use the state variable for coding. The state variable is an integer that you can use to record the robot's states while running. The state variable can be used as both a condition and an action. When the state variable is included in the condition, it means the robot needs take certain actions. When the state variables set are fulfilled, a range of state values need to be specified for condition setting. When we add the state variable as an action, it means that when the condition is met, the robot is set to the given state. In this case, only a single state value needs to be specified. In this task, let's specify that the robot is in state 0 before it reaches the blue marker. It will be in state 1 after passing the blue marker. In state 0, the robot turns left when it senses the red marker. In state 1, the robot turns right when it senses the red marker. Please rewrite your code using the state variable. The sample code can be found in the PPT slides. Well done. You have completed all tasks. Let's move on to the CoSpace Autonomous Driving Online Challenge. Let's work on the CoSpace Online Challenge, or as we call it, the iCool Challenge. Double-click on the CoSpace Auto-Driving icon on your desktop. First of all, you need to select the correct level. Then select iCool Challenge tab. Choose the challenge map you will be working on. Analyze the map and complete the code. We will use CoSpace Auto-Driving first steps as an example for illustration here. Save and build. Load the DLL from the control panel. Click on the Start button and monitor the robot's performance. When the robot reaches the finish line or when you click on the Stop button, an ICS file will be created. Save the ICS file and send it to the event organizer. Congratulations! Well done!
RCAP CoSpace Autonomous Driving Challenge Rules, U12 category. This category is for students aged 12 and below. Welcome to the RoboCup Asia-Pacific RCAP CoSpace Challenge. Automation of routine tasks is currently a concept that interests many industries. Among the most revolutionary parts of it are autonomous vehicles. These are visions of the future of city infrastructure. The main ideas they all share are self-driving cars and shared mobility. Those are set to revolutionize the ways we navigate through cities. In CoSpace Challenge, teams are required to build a real robot, develop and program appropriate strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. In the CoSpace Autonomous Driving Challenge, students are required to plan an optimum path, code both real and virtual robots to navigate in a smart city. The autonomous car needs to pass multiple waypoints before reaching its final destination. In this smart city, there are roads, buildings, color markers, black and white lines, and waypoints. In the iCool challenge, there will only be a virtual robot. The robot has an IR sensor array, an ultrasonic sensor, and a RGB sensor. Students need to utilize the elements in the smart city to plan the best path and program the robot accordingly. Let's take a look at the game process. The duration of the game is 8 minutes. That means the robot has to complete the whole journey within 8 minutes. At the beginning of the game, the virtual robot is placed at the start station. When it travels towards the finish line or end station, the robot must pass all waypoints in any sequence. It does not need to stop at the waypoints. The game ends when the virtual robot arrives at the finish line in the virtual world. If the virtual robot passes all waypoints and reaches the finish line, the team rank is determined by the race time at the finish line in the virtual world. If the virtual robot is not able to pass all waypoints, regardless whether it reaches the finish line or not, the race time for the virtual robot to reach the last waypoint will be recorded. The team rank will be determined based on the number of waypoints passed, followed by the race time.
The detailed rules can be found in RoboCup Asia-Pacific official website. After finishing CoSpace Auto-Driving U12, you can move on to study more advanced contents in CoSpace Auto-Driving U19. It aims to strengthen the RoboCup spirit with continuous outreach efforts through promoting robotics and AI to the general public. On RCAP Academy YouTube channel, there are plenty of videos on CoSpace Grand Prix, which is former auto-driving, CoSpace Rescue and other RoboCup categories. It includes step-by-step guidance on CoSpace Auto-Driving and CoSpace Rescue, teams sharing, highlighted games, tips and tricks, etc. They are ready for you to explore.